In almost all chemical reactions, not only are starting materials converted to products, but heat is also either given off or absorbed. In this video, we are going to explore the terms that apply to either the absorption or the release of heat. Specifically, we're going to look at exothermic and endothermic reactions and factors that affect the rate of a reaction. 3 conditions for a reaction must be met for it to occur. You must have a collision. The reactants have to engage each other. They have to be in the correct orientation, so there must be proper alignment to break and form chemical bonds. And finally, there must be enough energy for the collision to occur and the reformation of chemical bonds. In an exothermic reaction, heat is released. So heat is a product of the reaction. The energy of the products is less than the energy of the reactants. So here we have what's called as a reaction coordinate. On your y-axis we have energy. On our x-axis we have the progress of the reaction. Here we have the energy of the reactants, R, and then we have the final energy of the products. So in an exothermic reaction, the products will be lower in energy than the reactants. This barrier here, from the energy of the reactants to the peak, is known as the activation energy of the reaction. So it's one of the requirements to get the reaction to occur. If you look here at the chemical equation, we can see that it is balanced and it is exothermic because heat is a product. It is written on the right side of the reaction. In an endothermic reaction, heat is absorbed. So the energy of the products is greater than the energy of the reactants. Heat will be a reactant. So let's look at our energy diagram, our reaction coordinate. Again, we have energy on the y-axis, the progress of the reaction on the x-axis. Here we have the energy of the reactants. And then here you have the energy of the products, and you can see they are higher in energy than the reactants. We have now seen the barrier, okay, the activation energy is greatly increased here. Again, the activation energy is going to be the energy of the reactants to the top, the peak. This is the energy required to get the reaction to take place. If we look at our chemical equation, we can see that the atoms are balanced and we have heat as a reactant because it is an endothermic reaction. So let's do a learning check. We need to identify each reaction as exothermic or endothermic. We can see here that heat is a product, so it is an exothermic reaction. For B, heat is a reactant, so it's an endothermic reaction. And for C, heat is a product, so it is an exothermic reaction. Exo, endo, and exo. The reaction rate is the speed at which the reaction will proceed. So it is the speed at which we lose reactant or reactant is used up. It is the speed at which product forms. The rate of the reaction will increase as the temperature increases. This is because as we increase the temperature, we increase the kinetic energy. If you remember, kinetic energy is the energy of movement. So as we increase the kinetic energy, our molecules are moving faster. The faster they move, the more they can collide with each other. The more they can collide with each other, the more likely they are going to be in the correct orientation and be able to traverse that energy of activation and form products. So the rate of reaction will increase as the temperature increases. In addition, the rate of reaction will increase as the concentration of reactants increases. As we increase the concentration of reactants, we have more stuff that can react and collide. So again, remember, chemical reaction is all about collision in the right orientation with enough energy. So the more stuff we have, the more likely we are to collide and have productive chemical reaction. A catalyst will allow us to increase the rate of the reaction because it will lower the height of that energy barrier. So a catalyst is going to affect the height here. It does not affect the energy of the reactants or the products. So it will not affect how much heat is either absorbed or released. What it will do is it will lower the amount of energy needed for the reaction. So again, a catalyst is going to lower the energy of activation and therefore speed up a reaction. So table 7.7 summarizes the factors that increase the reaction rate. If you have an increase in temperature, you have an increase in kinetic energy, you have more collisions with the correct energy of activation. If we increase the reactant concentration, we have more stuff that can bump into each other, we have more collisions, we increase the rate of reaction. If we add a catalyst, we're going to lower that energy of activation and we're going to increase our rate of reaction. So let's do a learning check. Let's state the effect of each on the rate of reaction as increases, decreases, or has no effect. Increasing the temperature will increase the rate of reaction. Removing some of the reactants, well, that's going to decrease the rate of reaction. There'll be less collisions if we're less concentrated. Adding a catalyst, that's going to increase the rate of reaction. Placing the reaction flask in ice, that's going to lower the temperature, so that's going to decrease the rate of reaction. We're going to decrease the kinetic energy of the molecules. Increasing the concentration of one of the reactants, that should increase the rate of reaction. So let's do another learning check. Here it says, indicate the effect of each factor listed on the rate of the following reaction as increases, decreases, or no change. So pause your video and answer the question. You should see that raising the temperature will increase the rate of reaction. Adding oxygen is increasing a reactant, so it's going to increase the rate of reaction. Adding a catalyst will lower the activation energy, so that will increase the rate of reaction. And if we lower the temperature, that will decrease the rate of reaction because there'll be less kinetic energy and fewer collisions. So this concludes our discussion of energy in chemical reactions.